Hi everyone, the Amity stage is going to continue. We have a good speaker, I believe, someone that you definitely know from Wasabi. Max was just on the stage, and I think that he will introduce more new content right here, talk about how to use Bitcoin as was intended. So please give it up for Max, and let's see all your questions, everything. This should be an interactive session. Feel free, join in, and enjoy.
Thank you. So, I've been interested in Bitcoin privacy for some time, so let's talk a bit about it. If you have any questions, just feel free to shout them out. What is the problem with Bitcoin's privacy model? When we look at a block explorer, for example, in Mempool.space, and we see lots of random transactions coming in. For example, this one. Right? We have a transaction which has the plumbing spell. You see it? Yes? Okay, good. So you have the plumbing spell, and then output, it's the address where the plan is being set to. You know exactly that, for example, how much Bitcoin is being transferred. Exactly. So we see that one person is selling to someone else. And these are all very publicly facing. It's easy to just look at another transaction and see. This one, also the same looking. Here, for example, we have an interesting looking transaction. Right? We have one input and like 100 outputs. Right? So this is also very interesting. Here, this seems like one person is paying quite a lot of people. Right? He's not just sending the money to one address, he's actually sending it to hundreds. So if we look at this, what this might be, for example, an exchange. Exchanges receive fiat and send people Bitcoin. And the more users they have, the more Bitcoin they have to send. And instead of doing 100 different transactions where they pay each user in one individual transaction, they batch the transaction together. So you pay 100 people at the same time in one transaction. And the reason why people do this is because it's cheaper. On Bitcoin, we have to pay for each byte in the transaction that we do. So the more inputs, the more outputs we do, the more expensive it gets. But also, when you do multiple transactions instead of one, this also gets more expensive. Simply because, let's say this person is sending 0.53 Bitcoin, that's the value of the inputs that it's spending. And he is paying 100 people, but it's very unlikely that these 100 people get paid exactly the 0.53 Bitcoin. And it's much more likely that he's only going to pay 0.4 Bitcoin, let's say. And then, in such a case, for example, here, we have a 0.3 Bitcoin output. So this might be the change output that gets back to the exchange, right? So it started with a 0.53 and sent around, let's say, 0.2 to its users, and 0.3 goes back into the own pocket of the exchange. And then, for example, we could check out where did that exchange spend its money next. For example, here, this 0.31 coin got again spent in a one input, one output transaction. So this is basically how easy it is to just browse through the Bitcoin blockchain and see what's happening. You can always trace the money back as well. We can see here, this is likely the exchange as well, maybe doing some internal wallet transfer. Here again, the exchange made another payment. Right, so now we've identified two transactions that are very likely from the same person because they look very similar. Right, they have a rather large input, here 0.9 Bitcoin, and then they make a transaction with hundreds and hundreds of outputs. So now with this 5-second analysis, I'm half-assing it, right? But I just identified these two transactions belonging to the same person. That's not great, right? And anyone can do that without much skill. And this is a very, very basic tool. Mempool.space isn't a chain surveillance technology. It's a basic block explorer. But there's software that is tailor-made to spy on users like this, where all of these actions are just fully automated. And you click on a button and you see exactly that this one user is making all of these transactions. This is the people that he's involved in. This is the way that the receivers of this transaction are spending their money. And there's basically an infinite chain of analysis possible for who is paying whom and how much money is left over. So this is quite a serious problem. But thankfully there's quite a lot of good solutions for this. Now the question is, how do we find a coin join? How it is. We can, for example, mempool.space do some basic analysis. You can see, for example, this is what's going into the next block. And out of this, these transactions are all consolidation transactions. This is, for example, what transactions we haven't yet talked about. But this is what a consolidation transaction looks like. You have hundreds of inputs, and you only create a few outputs. So this might be, the pizza merchant. He's selling pizzas all the time, and he gets paid from a lot of different people. And then at the end of the day, he takes all of the little coins that he received, he spends them, and he creates one large output with the entire value that's left over. Right? But now, for example, all of these addresses that you see on the input side all of these here are two different addresses. Just before this transaction, we had no idea that this coin and this coin and this coin all belong to the same people, or the same person, because each address was random and unique. Right? So when you generate a new address and someone pays you, and you do that again a second time with a new random address, nobody knows that these two random numbers are controlled by the same person. However, once you make such a consolidation transaction, where you do spend many coins on the input side right away, then now it becomes very easy to see that, hey, this is one person who has all of these addresses that were previously just random numbers. Now we have this additional metadata point of, look, all of these addresses belong to the same person. And that same person is making a payment here, right, worth 0.18 Bitcoin. So not just have we found out that all of this merchant, like the merchant who has received many times in the past, we found out all the transactions he received in the past. We're also simultaneously finding out where is he spending his money, right? And what is that other person doing with the money that we sent it to? So yet another easily identifiable, transaction that just shows it. So how do we best get a coin join? If you have any questions, right, always just shoot them out. I'll keep elaborating until you get bored. So keep it entertaining. So it seems like here we have a bunch, yeah? Okay, we'll just click through until we find a contract. Maybe this? That looks like one. Voila. Here we have a pretty large CoinJoin. So as you can see, CoinJoin is unique that it has many inputs and many outputs. Hundreds of them. In fact, this one has like 310 inputs and 315 outputs or something. And the cool thing is, in a CoinJoin, we know that all of these inputs are not belonging to the same person. The CoinJoin is by definition a transaction coordinated with many users. Right? So instead of you individually making a transaction with your one input, two outputs, and you making another transactions with two inputs, three outputs, for example, you can come together and make one transaction with 5 inputs, 6 outputs, or whatever. So this means we can just all team up, hundreds of us together, and we create one large transaction with many inputs and many outputs. And so if we look at one, let me make this bigger. If we look at just one input or one output, for example here, input worth 1.34 Bitcoin. let's say we know that this is the coin that we sent to the Lambo merchant when we're buying our Lamborghini, right? So we know for sure this coin worth 1.3 Bitcoin belongs to the Lamborghini merchant. Okay, cool. Now the question is, which output belongs to this Lamborghini merchant? If we know exactly this input is from our victim, which of these outputs belong to our victim? It might be that you got a 1.29 bit, for example. But there's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times, 12 different coins to 12 random addresses that sent the exactly same amount of money. So, which of these coins did our Lambo merchant get? One of them, probably, but we don't know exactly which one. And we are not even sure that he got any of these 1.29 Bitcoin, because look, here is a 0.67. He put in 1.34, that's 2 times 0.67. So he might not even have gotten this big one at all. And if we keep scrolling, and pick another random example, we for example also don't know that this guy with the 1.3 Bitcoin, does he have any of the other inputs? Right? Does he also have this 0.2 Bitcoin inputs? We don't know. But if he has lots of, let's say, small inputs, then one person that's like 5 times 0.2 can get a 1 Bitcoin output. And so you can either consolidate many coins into one coin, or you can just have one coin on the input side and fan it out into hundreds of outputs, or you can just have one input, one output. All of this is possible behavior for users inside this transaction. And frankly, nobody knows, other than the actual user who made this transaction, of how many inputs and how many outputs the user has here. So this is the basic of a coinjoin transaction. It's quite simple, really. It's just another Bitcoin transaction, which is making really, really big with lots of people. And then it becomes extremely difficult to analyze what's going on here, which is a great feature for Bitcoin. Yeah. Any questions? Anyone has anything interesting to talk about? Anything I should follow up on? Yes? Keep rambling. So, how do we actually use this thing? This technology is quite old. It was first discovered in like 2010 or something like this. That might actually be interesting to look at. There is coinjoins.org, which is a website about the basics of a coinjoin transaction. Right? As you can see, many inputs, many outputs, as well as the history and an analysis of different implementations throughout the time. So here again, you see the basics of a Bitcoin transaction: 3 inputs, 3 outputs. It's pretty easy to get a good guess at what's going on. You might not get a perfect guess, but you are very likely to have a correct guess, because there's not many guesses, right? This might be 1, 2, or 3 people making a payment. Cannot be more, right? So, Hashcoin was the name of the, Bitcoin Talk user back in 2011 that described the coinjoin technique. And it's quite interesting, because in the Bitcoin white paper, Satoshi Nakamoto actually says that there is such a thing that we can assume that on a transaction with many inputs, all of the inputs belong to the same person. Satoshi talked about this common input ownership heuristic already in the white paper. So he was basically teasing that there is a problem, but he didn't quite understand yet that there's a solution. And I guess after Satoshi left in 2011, someone else said, hey, by the way, this assumption that all of the inputs belong to the same person is not exactly how Bitcoin works. Bitcoin works perfectly fine when you make a transaction where 3 people own the inputs, each one of this transaction. The Bitcoin Consensus Protocol does not say that this is invalid. Bitcoin Consensus Protocol does not say that one person has to make a transaction. The Bitcoin Consensus Protocol just says there needs to be inputs, there needs to be outputs. The value of the outputs must be smaller than the inputs. All of the inputs have signatures, etc. Blah, blah, blah. But it has not even the concept of who is a person or who is the single user. Bitcoin just knows about coins. And so that's the cool thing that CoinJoin enables. So in 2013, Gregory Maxwell, which is another Bitcoin wizard with a beard this long, he made a blog post detailing the problem that exists with Bitcoin's privacy model and outlining CoinJoin as a solution. Right? Again, CoinJoin being this collaborative transaction. And then he even had one little sentence, that we can improve the privacy of this CoinJoin by using something that's called as Chaumian-like signatures. But everyone kind of ignored it at that point. This post was a bit discussed, but also what was really interesting, Gregory Maxwell made here a bounty. He set up a multi-sig, I think a 203 multi-sig, where people could donate Bitcoin to encourage developers to work on a solution that implements the CoinJoin protocol. And I believe, 40 Bitcoins got donated or something like this? Again, like in 2013, it was not much money. So there wasn't, I guess, much donation demand. That's a problem that lots of free software projects struggle with, unfortunately. But throughout the years, this bounty grew in value more and more. And then there were the first efforts after this bounty was announced to actually build something. So for example, AmityAge created a dark wallet, which was one of the early CoinJoin protocols or applications. It was very much a hacky proof of concept. It was like, here's the code, it kind of works, but it's not beautiful code, it doesn't scale well, it's not that robust. And, he abandoned it. It didn't really work that much for a while. But there was Shared Coin, CoinMax, CoinJuffle, CoinShuffle. Also at this point, academia got involved quite heavily. Numerous universities were publishing research papers on the algorithms that enabled the creation of such a CoinJoin. And ways to analyze it and somehow quantify the privacy models guaranteed. So this was a very academic research project as well. And then in 2015, we had JoinMarket launch. JoinMarket is the first serious CoinJoin implementation, something that was more than just a proof of concept, something that was meant to stick around and be maintained for a while. And it is still being maintained today. How old is it now? 9 years. It's wild. So JoinMarket is a model where there's hundreds of users using the JoinMarket software. JoinMarket is running on top of your Bitcoin full node. So in order to use JoinMarket, you need to have a Bitcoin full node, because you need to create private keys and find out how much money you have, etc., and send to Bitcoin. But then there's basically, out of all of you, there's one person who would really like to make a transaction now with a certain amount of money, let's say 1 Bitcoin, but you would like to make it private. So you would like to do it in a CoinJoin. But for privacy, you need to have a crowd. You need to have your friends to hide with. And now you can, so all of, let's say, the other people here, they are people who would like to make a CoinJoin, but they don't really care about the amount of money that is in this CoinJoin. They don't care if it's 1 Bitcoin or 0.5 Bitcoin or 1.23456. It doesn't really matter. These people just want to make a transaction to improve their privacy, and they don't even care when. It can be now, it can be in an hour, it can be in a week. Just whenever someone wants to do a transaction, I'm ready for it. So these people are called the makers. They are people who are always online, just waiting for making a CoinJoin at any parameter. And you are the taker. You want to make a specific CoinJoin for a specific amount at a specific time, like right now. And so you connect to the makers and look at the order book of who is willing to make a CoinJoin with what amount of money, with how much fees, etc. And you pick 5 of them, let's say. And so we have 5 makers and 1 taker, which now coordinate the creation of this CoinJoin transaction with, let's say, something like 6 inputs, 10 outputs, or whatever. And the taker talks with all of the makers and helps them create this transaction, and then sends it back for everyone to sign it. If all of the makers and the takers, if every input owner signs this transaction, it is a valid Bitcoin transaction, and we can broadcast it to the network. Now, of course, the big question is, why would these makers actually even talk to you or make this transaction? Because, well, they need to be online, they need to spend their Bitcoin. Why would they go through all of this hassle? And the easy answer is, you just pay them. The person who wants to make a specific coin join right now pays the people who are happy to make any coin join at whatever time. And this is how JoinMarket works. It is a market for joining your coins with others, so to say. And the beautiful thing is, there is not one single entity that controls this network. There's hundreds of users. Any of this user can become a taker. Any of these users can become a maker. And we just need to have some bulletin board where we find each other. So it's a very resilient, distributed, and censorship-resistant protocol of finding people to make transactions with together. And very beautiful. It's absolutely genius design. And yet, still around to this day. Much more user-friendly nowadays than it was in the past. So yeah, in November 2016 was, this time where a lot of alternative proposals also discussed. Things like, for example, payment channels, which is now the Lightning Network, is a privacy and scalability solution. Tumblebit predates the Lightning Network payment channels, which was a, let's say, privacy-optimized payment channel between two people. Extremely complex protocol. Like, I still don't get it, and I think even the person who created it doesn't get it anymore. At least he forgot it too. So nobody gets it at this point. And that's, by the way, one of the huge benefits of CoinJoin compared to something like Tumblebit or even the Lightning Network. CoinJoins is extremely simple. It's such a simple and elegant protocol. It's like 3 API calls basically, and it just works really, really well. And it's easy to implement too, and it's very secure for the end user. It's very difficult to build a CoinJoin software that makes you lose money. Now, if you know a little bit of what you're doing and you have some peer review, the CoinJoin implementation is going to be unhackable and stealable, so to say. So Tumblebit was one approach, but then the creators of Tumblebit realized that, this is too complex, this doesn't make sense, we need something else. And then they started with the creation of the zero-link CoinJoin protocol. So this is also a CoinJoin protocol, meaning users making a transaction together. This is also, just like JoinMarket, a centrally coordinated CoinJoin protocol. Right? In JoinMarket, there's one taker. He is the coordinator. He chooses, the other people to join, and he can kick them out if they don't behave, if they don't sign the transaction. But the problem with JoinMarket was that the taker can spy on all of the makers. You know exactly that this guy has 2 inputs and these 3 outputs, for example. So even though all of the makers get quite good privacy against outside observers, people just browsing the blockchain like I did earlier, JoinMarket works great against this. But if your adversary is the taker, or for example if the taker got hacked or something, then you have a problem because that person can be anonymous. But that was where the zero-link protocol came in. As I said earlier, in 2013, Gregory Maxwell, in this introductory post to CoinJoin, he had like this half sentence. Oh, by the way, we can use strong inline signatures to improve the privacy against the coordinator. Full stop. Everyone kind of ignores it. Until the creators of ZeroLink reread this and really tried to understand what it means and turned this into an entire protocol, such that we have a central coordinator again, where people can register their inputs and their outputs and their signatures, but in such a way that even the central coordinator does not know that these inputs belong to these outputs, inputs and outputs to the same user. And that's quite a tricky thing to solve technically. Just to break it down a bit, is we basically have an anonymous API. Anyone can talk to this API. You don't need to have an bytecode or an access, basically, it's just a public API. However, the API needs to give a certain form, and then if we allow anyone to register outputs to our transaction, then what prevents this guy from just registering 1,000 Bitcoin on the output side? Because, he would like to get 1,000 Bitcoin on his address. Why not? Everyone would like to have 1,000 Bitcoin. But if the coordinator allows this, then we have a problem, because we have now a Bitcoin transaction with 1 input or 1 Bitcoin on the input side and 1,000 Bitcoin on the output side. That's not a valid Bitcoin transaction. We're spending 1 Bitcoin, creating 1,000 Bitcoin. That's inflation. That's not how Bitcoin works, right? So we somehow need to limit access to the output registration API to the users in such a way that only a user can register an output, if that user also registered the input before. So we need to verify, the board needs to verify that you can only register an address to be paid if you also provide inputs, the coins being spent, of the amount larger than the payment that you want to do. And you need to have at least 1,000 Bitcoin in order to make a 1,000 Bitcoin address. And we do this anonymous API access right management with anonymous eCash tokens. All the way back 1983, Chaumian eCash, ancient, extremely simple cryptography protocol that enables anonymous transfers of a token. And so basically we create a token whenever a user registers a valid input. Let's say you register 1 Bitcoin input, then you get a token worth 1 Bitcoin, but not actually worth the amount of sats. You cannot get Satoshis for this token. But what you do get is that I allow you to register on the output side an address worth 1 Bitcoin, only if you give me this token worth 1 Bitcoin. And so we have the creation of an access right token when users register an input, and then the coordinator requires that you have such an anonymous token in order to register the outputs. This is how we ensure that there is no inflation inside the transaction without relying on identifying who the users are. We don't need to know that this user put 1 Bitcoin in and took 1 Bitcoin out. We don't need to know that. I just need to have a proof that the user didn't create more money than he had. But I don't need to have a proof that follows the money, so to say. It's a zero knowledge proof. I know that he didn't create any money without knowing how much money he used, so to say. Cryptography is weird like this, but it just works. So it's magic. So in any case, this is the zero-link protocol, and this was then implemented by Wasabi Wallet in 2018. So yeah, this research started around 2017-ish, and then in 2018, we have the creation of Wasabi Wallet 1.0. And here the realization also in the zero-link research was that we can have a great on-chain privacy. We can even have great privacy against the coordinator, but if we have a bad wallet privacy, a wallet synchronization privacy, then all of this is for nothing. Because in the past, either, like, in order to be private, you have to run a Bitcoin full node. That's why in JoinMarket, you can only use it with a Bitcoin full node. But that takes a long time to run, requires some storage. So people prefer a wallet to synchronize faster, to not need that much bandwidth, to not need so much compute. So people use light clients. A wallet that does not have a full node, but a wallet software on your phone or laptop that connects to someone else's server, and that other person has a Bitcoin full node. Okay? And now you generate addresses on your phone, and to send those addresses to the backend server, asking the other guy, hey, can you check on your full node how much Bitcoin is on this address? Which is cool. He can respond to you super quickly of, yeah, you have no Bitcoin on this address, or voila, you have 1,000. But the downside is that other person knows all of your addresses now, including the addresses of your inputs and of your outputs. So even if you make a coinjoin where it's impossible to link the inputs to outputs by just looking at the transaction, if you reveal yourself to the wallet service provider, the wallet synchronization server, with, hey, here, all of my addresses, then of course that guy can follow you from input to output. And so Wasabi Wallet also addressed this problem as well by a technology called block filters. So it's still a light client. You don't need to have a full node in order to use Wasabi. Someone else has the full node, that's the backend server. But you can now find out how much money you have without ever sending your addresses to that backend server. Your addresses always should stay on your machine, and you can find out how much money you have without asking someone else about the balance of this specific address.
So we're talking about
Yeah, so the question is about a pooled node. By default, the Bitcoin full node keeps a copy of all of the blocks that has ever happened, right? All 840,000 blocks. It's like 600, 700 gigabytes, right? A lot of data. And we keep this data around so that for future generations, they can come online and download all of the old transactions that happened, right? So we're doing it for the kids. But you're not doing it for yourself. Because once you have downloaded and verified the block, you don't need to keep the entire Bitcoin block in order for it to be useful. You can delete most of it, and you keep a tiny portion of the block, and Bitcoin will still work for you. You only need to have old blocks if you're synchronizing a wallet from scratch that was used in the past. But let's say like 10 years from now, you somewhere discover 12 words sitting around and you want to find out do I have money in this, then you would probably want to check since at least when you got into Bitcoin, or most likely since block 0, if these addresses ever got made. So for that, then you need to have all of the old blocks. But once you have downloaded and verified this, you can toss away the block. Just keep checking new blocks as they come in and delete them. So you can get the storage requirements for Bitcoin full node down to like 10 gigabytes or something. Then it's not that much anymore.
Yeah, so this kind of production I want to have this
Okay, so for CoinJoin, the end user does not need to have a full node, right? But Wasabi Wallet clients don't have a full node. They can sign CoinJoin transactions just fine. The coordinator does need to have access to a full node in the current software implementation, right? And currently it's even in archival mode. So currently the coordinator has all of the blocks, he has a transaction index, which is an additional piece of data that he has to keep. So it's you need like almost a terabyte of storage or something to run the current implementations. However, it's not a technical requirement to have a full node as a coordinator. You can have a pruned node, for example. You can delete old blocks and still coordinate CoinJoins just fine. And you can even use something like mempool.space API. You can just use someone else's full node, and just every time a user registers an input with you need to make an API call to mempool.space or some other full node server and ask them, hey, is this address paid? Or does it exist? And if that full node server says yes, you allow the account to be registered. But the actual computer that runs the coordinator doesn't even need to have a full node, at least in theory. Not in practice, but hopefully so. So yeah, running a coordinator is extremely lightweight. So the way that Wasabi Wallet is designed is that it's a very smart client, it's a very dumb server. The server is maybe 10% of our code base. Right? It's very small compared to the client. All of the complexity, all of the privacy guarantees, all of the defenses are all in the client side. Because Wasabi Wallet is built in such a way that we do not trust the backend server. We assume that this backend server is malicious, that he's trying to steal from us, that he's trying to spy on us, and the client does all it can to protect the end user, not just against malicious outside people, but even against malicious coordinators. Well, that's very difficult actually to implement that in code, so take this with a grain of salt. So it's more like, this is the aim. We are trying to build code that makes it impossible to steal from users, even for the person coordinating the runs. It's just very difficult to build perfect code, so there might still be bugs and unknown things that we haven't talked about. So, yeah. But so far, so good. I don't think anyone has ever lost money in Wasabi. There was one edge case bug where a user was running 2 Wasabi wallets on 2 different computers, and he put the same set of 12 words in 2 different wallets, and that caused some issues where he was actually sending more money to the coordinator. We gave him a bug bounty and sent the money back, plus on top of it for finding this out, and we fixed the bug. But yeah, so it's always possible for this code to mess up. But if it's done well, it should work. So yeah. We have 3 more minutes. Any final questions? If you have any pressing matters. Otherwise, then, yes, in February 21, we did a research project for Wasabi. This is after ZeroLink, the next generation of CoinJoin protocols. We invented some new fancy cryptography for it, basically a new eCash system. This anonymous token as API access right management. And we made it just a lot more flexible. The protocol is much, well, it's not really simple. It's still a pretty complex protocol, but it allows the user to be much more flexible. Now you can do all types of use cases with this. This is not just something that everyday people, who stack on an exchange and do some coinjoins before they send the money to a hardware wallet. This is also doable for the actual exchange to use this. And as we talked earlier about these batch transactions or consolidation transactions that exchanges frequently do, you can do this in a Wasabi coin trust, which wasn't possible in the past. So with Wasabi, you have a really flexible and customizable protocol to help users coordinate these large collaborative transactions. The protocol is super solid. It works well. So if you are builders, build something with it. If you're users, check it out, have fun with it. And thanks a lot for coming. See you on the next one. Bye bye.